Now let's take a look at viruses, worms, and Trojan horses. Basically, if you're lucky, they just occupy some CPU time and disk space, if someone is lucky. If someone is not lucky at all, they result in destroyed data, losing control of your computer at all. So when we look at the basic differences between them, the computer worms can self-replicate and they do not need to attach themselves with existing programs. They spread on the network. Computer viruses can self-replicate again, but they usually attach themselves with existing programs. And Trojan horses work in a different manner. They cannot self-replicate, but they use usually social engineering techniques to trick the victims to install their applications. That's the idea. Let's take a look at them one by one. The viruses are self-replicating codes embedded within another program called the host. Let's take a look at some of the famous ones. In 1986, there was a virus called the Brain, which was spread from Pakistan. And what else? In 1991, it's another virus, Michelangelo. I don't know this one as well, and it's from the history. How it operated was, if an infected file run on the March 6th of year, because it's Michelangelo's birthday, it overwrites critical records on boot disk. Media reports of that time show that over 5 million personal computers were infected. A true investigation revealed only a few thousand computers. In fact, they spread the news like this, but when they made a true investigation, it is in fact really a few thousand computers at all. Media likes this kind of stuff. In 1999, Melissa virus, I remember this one, which was an email attachment in a Word document. What it does is it targets 5 people from your address book, from the victim's address book, and sending the same message to all of them as well. It really resulted in crashing the email server because look how exponential it is. And 100,000 computers were infected at the first weekend, and it spread. It was spread by David Smith's Usenet group post here. It was a bulletin board, and he has been fined with 20 months in prison and plus 100 hours community service plus $5,000 fine. It was a famous and harmful virus of its time. In 2000, the love bug, again I remember, it was sending to everyone in the victim's address book this time, creating more traffic, as you can guess. And it collects passwords and emails in Philippines, and in fact the creator was a 23-year-old Filipino computer science student, and since no laws established against hacking in Philippines, there was no trial at all. But lots of computers and users were harmed, and it was even shown on the cover of Time magazine that time. And what about the worms? Their self-contained programs spreading through network computers using the security holes in that systems. Like for example, anti-nuclear protesters, a case of cyber terrorism that it can be said, trying to delay a launch, but it took a lot of time for the system admins to clear it. This one, like the wank worm, it didn't result in a delay on the launch, but it took lots of system admin time to eradicate the worm of that time. This is the oldest one in history, like in 1989, where NASA was trying to send a probe to Jupiter named Galileo, and it was filled with radioactive plutonium, and the nuclear protesters were acting against them. That's the idea. And 2001, I remember this, it was code red, Microsoft Internet Server bug, and affecting Windows web servers. It is based on the day of the month and doing different functions in different days of the month. The first one is propagating the others. The second behavior was creating distributed denial of service attacks against the White House, and the third one was making the system, doing nothing. It was just sleeping and doing nothing. It infected more than 350,000 hosts in just 14 hours. So it was spreading quite easily, and it was a Chinese one, as we know. And again, this one was a famous one in 2003. Sapphire, and also known as the infamous name Slammer. It was the fastest spreading worm in history. It was doubling in network every 8.5 seconds roughly, and within 10 minutes 90% of vulnerable hosts got infected. At least 78,000 computers worldwide had been infected. These are just estimates, and it was in fact a SQL Server and SQL Desktop Engine bug. There was a weakness there. It was not malicious, but overloading the networks and resulting in inaccessible databases, where some of the airline flights were cancelled, some of the ATMs were unavailable for a while, and it also resulted in failures in emergency call services as well. You see how it spreads in the world as in 2003, how quickly it spread. And again, within the same year, 2003, Blaster Worm was exploiting a bug on Windows 2000 and Windows XP computers, and resulting in denial of service attack against Windows Update com site as well. So it was also, with this attack, it is preventing the users to download the patch as well to fix that bug. It actually targets a shortcut to the site address, and Microsoft then deleted the shortcutted address, but then they fixed this later. It was slowing down systems, and it also disrupted signaling of various automatic train systems of that time. And 1 year later, in 2004, Sasser Worm, already known, it was exploiting an already known security weakness in Windows computers again. This time, massive amount of computers, like 18 million computers, were infected without the patch. And it was benign, but forces shut down after the reboot. I was also infected with this. It's in fact very annoying, but other than this annoying rebooting thing, it didn't do any harm at all. But of course, it disrupted the operations of the Delta Airlines, European Commission, Australian Railroad System, British Coast Guard System, and numerous other systems' daily tasks. Microsoft put $250,000 reward for a headhunt. Find that person who created this. And in the end, it came out that a fellow student, a German teen, Sven Jashan, he was just 17 years old when the worm was released. So he was convicted in a juvenile court because he was not an adult, and resulting in 1.5 years probation and 30 hours of community service fine. Then he has been hired by the German security firm, the famous Secure Point later. He got some job there. And there are also instant messaging worms. In 2001, the first one, the notable one, was Choke and Hello. It didn't cause much problems because only almost 150 million people had been using instant messaging back in 2001. Not popular like this today. It became popular later on. And in 2005, Calver and the Reuters News had to remove 60,000 subscribers from its Microsoft-based instant messaging services for 20 hours to tackle this instant messaging worm. It was causing lots of trouble. And the most infamous one in history was the first internet worm. And it was done by Robert Morris Jr., who was a Cornell computer science grad student that time, launched a computer worm in 1988. It was the most sophisticated worm of its time. When a site gets infected, it would signal to a popular computer system at Berkeley called ERNIE. It is his like he was just trying to address an issue here. It was targeting Unix operating systems, where Robert Morris was expert at Unix operating systems even at high school. His father was a computer security researcher at Bell Laboratories, and Morris focused on security holes in Unix systems. He tried to contact many authorities of that time, but maybe he was disappointed about the responses, I don't know. And when he was an undergrad student at Harvard Computer Science department, he quickly became Labs Unix expert of that time. After freshman year, he worked at Bell Labs 2. And he wrote technical reports on the security hole of a Berkeley Unix system as well at that time. Morris then enrolled as a computer science grad student in Cornell at fall of 1988. He was trying to exploit the bugs he found in 3 Unix applications that time, namely FTP, SendMail, and FingerDaemon applications had some bugs. That's his idea. It was what his worm was doing was a buffer flow attack to take the control of a target computer, and it's overflowing those buffers based on the function calls. It is also doing a variable attack where it targets a variable by buffer overflow again, and stack attack again, changing the value of the return address of the function of the call to make invalid operations get the main control of doing his wish list of 24 goals, including the worm had to accomplish 24 goals, lots of functions embedded within this worm. It was infecting 3 machines per LAN per network, and it only consumes CPU cycles if machines are idle. Pretty interesting. And it would avoid slow machines, so it detects if the machines are slow or not, and it would avoid them. And it would break passwords to spread into other computers as well. These are just 4 of the goals of the 24 goals of this particular worm. In November 2 of 1988, FTP bug fix had been posted to the internet, and the FTP infection, file transfer protocol infection, was done. In fact, not working of this worm, but there were still bugs in SendMail and FingerDaemon applications, and they were still vulnerable. So he logged to MIT AI lab and launched the worm at 7:30 in the morning. And immediately thousands of computers at military, medical, and university facilities are infected. It happened very fast. Unfortunately, computers became infected with hundreds of copies of the same worm, causing crashes every few minutes. Within 43 hours, within 2 days, the worm is isolated, decompiled, and destroy notices are spread. In fact, worm did no permanent damage but slowed systems to stand still and acquired passwords as well. This was a problem. And Morris kicked by the university board immediately. I mean, he has been kicked out of Cornell, and trial held in 1990. Morris revealed that he tried to stop the worm, realizing his mistake, and contacted a friend from Harvard, in fact, Andrew Sudut. And he defended that I did my best to contact my friend in Harvard to stop if something can be done. Andrew Sudut confirmed the request, but solution couldn't reach because of the clogged networks. About 6,000 Unix computers were infected with the worm that time. And here is the Andrew Sudut's message here, that he tried to help the people. There may be a virus on the loose, and here is the gist of I'm sorry. He's saying that he's sorry. Here are some steps to prevent further transmission. Like these should be steps to stop the spreading of the worm. In fact, Morris had written this to stop the worm from spreading. But in fact, this message couldn't reach its destinations. Harvard's computers not affected because they already had patched the security holes, but Sudut, in fact, at that time can still not believe Morris's story. His mail was supposed to be routed over the computers at Brown University. At that time, this was the type of connection in 1988, but Brown University computers were already down with the worm. The message subject was also blank anyway, and message read too late, so damage was done. Morris found guilty in the end and sentenced to 3 years probation plus $1,000 fine plus 40 hours of community service. It could easily be increased to 5 years in jail and 250,000 fine if no good defense, and they say that he did his best to he was regretful and tried his best to stop it later. His legal fees and fines in the end, but unfortunately exceeded $150,000 because even if the fine was this, legal fines and fees exceeded this amount later. So it costed him a lot of money in the end, this trouble. Morris' defense was, I was trying to expose a flaw in a system because system administrators didn't listen to him. He didn't mean such damage, but worm got out of control. This is maybe close to similar to a whistleblowing incident, but we will see if it is really the case. And if you wonder what happened to Morris Jr. Later, he works as a professor at MIT now, so he's teaching now. Then he was a very famous person of that time. He's still very good in this area, we can say. And the Trojan Horses, what are they? Those are the programs with betting capability, looks like that, but they conceal another sinister purpose. As you see, they come embedded within other programs. And how do you get it? By opening an internet connection for an outsider to gain access. When you get it, there will be backdoor for the attacker to your computer, your device. What can they do? They can log keystrokes, get your passwords, and do several types of reporting to the attacker. And it can also destroy files, and it can be used to launch denial of service attacks from the victim as well, turning your computer into a bot. And turning your computer into a bot to launch spam and commit various kinds of illegal activities. These are called the remote access Trojans, right? shortly access to victim's computer, and the most popular ones are back orifice and sub7. Sub7, they both have interfaces here, user friendly, you know, and the Sub7 is more popular because it has a more efficient interface. It's point and click. It's a very good one, and it's a client program is on the attacker, and server program is installed on the victim's computer, and it is able to capture screenshots, record keystrokes, read and write files, watch traffic. It can even control your computer, like it can control the mouse, and it can use your I/O devices as well. It's pretty interesting. And how it is distributed, it comes embedded to many kinds of files and applications, usually distributed as erotica files, or sometimes they're embedded within some computer games, cracks and hacks, whatever types of applications. And when you have a Trojan, it means that you can be a part of a bot network. And what are those bot networks? Those are a software program that responds to commands sent by a command and control program located on an external computer. And bot herders usually operate, or bot masters usually operate those bot networks. And they can do lots of attacks like spam and denial of service attacks, distributed denial of service attacks, and they can infect systems, they can do phishing. Any kind of malicious activities can be done over those bot networks. And bot supported legitimate apps are also available. Internet relay chat channels and multiplayer internet games are also can be used for that purpose. Over 90% of spam is distributed through bot networks, and some other bots are designed to steal personal data linked to identity information as well. And bot networks can also be used for distributed denial of service attacks, as we just discussed. Now, what are denial of service attacks? It is the intentional action designed to prevent legitimate users from making use of a computer service. Suppose that a server is giving service to a set of customers, and they will not be able to get that service from that device. The objective is not stealing here, instead disrupting a computer server's ability to respond to its clients. That's how it works in the denial of service attacks. It is an example of an asymmetric attack, and it can easily be linked with terrorist organizations, and there are lots of fears about the future over this issue. I mean, cyber war, or between particular organizations. There are some dystopic scenarios about this. In 2000, a 15-year-old boy launches a denial service attack, disabling many websites, including the popular services, popular companies like Amazon, eBay, Yahoo, CNN, and Dell. And this was his nickname, Mafia Boy. Was sentenced to 8 months in a juvenile detention center because he was very young, and 1 year plus 1 year probation as well. This was one of the most notable attacks of its time. And in 2002, again, denial of service attack to internet's widely used 13 root servers that matches IP addresses to domain names. We discussed those DNS servers before, and disabling them. A recent denial of service attacks target blacklisters usually. Like the CEO of Spamhaus says that we're usually under attack from 5,000 to 10,000 servers at once. usually, because they're blacklisting the, spammers or bots here, and they're also target of these attacks as well because they fight against it. The most primitive way of preventing a denial of service attack is just cutting off the network connection, right? It's pretty brute force, but very effective. So you secure your system physically first. That's the idea. And the flooding attack is where attacker sends a synchronized message by IP spoofing, and we just briefly discussed this as well in the previous slides. Like it pretends like it's coming from another device, and the target tries to get the acknowledgement message as well. So this is a typical TCP communication. Links stand by as many as synchronized messages. Server would be in trouble at giving service to legitimate clients. It's trying to acknowledge all of these synchronized messages, and it will be overloaded or incapable of answering all of them. This is called the flooding attack. And in the Smurf attack, the first identifying broadcasting routers in victim's network and using the ping echo scheme, spoofing again on target for this time, and echoes sent to target, and target's network gets saturated and unable to again respond to normal traffic or legitimate clients. That's the idea. There are also other types of attack, like filling available space on hard disks of the victim, like email bombing, worms that generate very long streams of errors, and computer logs errors and disk gets full rapidly, or breaks in victim and makes copies of files, so it will be multiplying exponentially, resulting in unavailable disk space on the victim. Or they can crash the victim by sending unexpected data types, such as an oversized IP packet or something, forcing the victim computer to a crash. Distributed denial of service attacks are done by bot herders and many bots operating from different places. Distributed DOS attack is a kind of Smurf attack from thousands of computers instead of only one. This time, thousands of computers doing it. Making it massively destructive and harder to deal with. There was one interesting approach taken by Blue Security company of Israel, and they installed a spam deterrent, or they applied a spam deterrent system. Like they tried to fight bots with bots, and they also sold this service to businesses as well, and it's free for end users. Users usually download a bot called Blue Frog, this was the symbol. You install it on your machine, and it is integrated with Yahoo, Gmail, and Hotmail, and many popular operators. It checks email messages for spam, and when a spam is identified, the bot contacts the Blue Security server to determine the source of the email. And this is the critical part. Then the bot would send the spammer an opt-out message automatically. So it means that whenever you get a spam from a location, you send the opt-out message as well when it is identified. So it means that you're spamming the spammer. It's something like this, and making the life harder for them. So spammers usually target millions of addresses daily, and they started receiving thousands of automatically generated opt-out messages, filling their networks, their own networks, and disrupting their operations as well with the use of this Blue Frog. What happened then 6 of the world's top 10 spammers agreed to use Blue Security's filtering software to remove Blue Frog users from their email list. So they accepted. They agreed to remove Blue Frog users from their email list, it means that they will, the clients of Blue Security will not be getting any spam from those spammers. However, one of them, four of them didn't agree, and one of them was who was called, you can read about this in Wikipedia or Google later, Pharmamaster, didn't back down. In fact, he even threatened the Blue Frog users, and sending a message like this: unfortunately, due to tactics used by Blue Security, you will end up receiving this message and other nonsensical spams 20 to 40 times than you would get normally. Like, it's a threat done by the spammers. Followed threats, and as of May the 1st, 2006, sending Blue Frog users 10 to 20 times as more spam as they would normally receive. They did what they proposed. The next day, Pharmamaster directed Blue Security itself and launched a massive distributed denial of service attack from 10,000s of other. It means that they control lots of bots targeting Blue Security servers this time. And first, of course, the Blue Frog services went down. Then he targeted other companies providing internet services backbone to Blue Security company. Then he targeted the businesses that pay for Blue Security services. So it means that it's some kind of cyber war maybe. And in the end, they were all down. So when Blue Security company realized that it could not, although they can deal with partially themselves, they can cope up with this much of spam, but they could not protect its business customers anymore from this massive distributed denial of service attacks and virus-laced emails, too many. It reluctantly discontinued its service, so Blue Security gave up this methodology to fight bots with bots. Aaron Rashif, CEO of Blue Security, announced that we cannot take the responsibility for an ever-escalating cyber war through our continued operations. So we are discontinuing all of our anti-spam activities in this sense. So that's the idea. It didn't work out. Blue Security's decision to fight bots with bots, this type of approach is always controversial, and it has been seen that it was ultimately unsuccessful in this sense. And in 1995, this again a notable event, a computer security expert Dan Farmer set up a security administrator tool for analyzing networks. It probes for security weaknesses automatically in the networks. It is shortly called Satan. And it had an easy to use interface, tempted teenagers into computer hackers because it's identifying the weaknesses. It's easy to create scripts for hackers to probe hundreds of sites and report their security holes. And Dan Farmer then admitted that the Satan is a two-edged sword that can be used for good and evil purposes. So it's not surprising. As it turns out, Satan-enabled computer break-ins never materialized. In fact, there was no significant damage, but this was a concern about that time. 2 years after his release, Dan Farmer surveyed the security of 2,200 websites, and it has been found out that 60% of sites were vulnerable to break-ins. About half of them had major security problems, even though all of the security holes probed by Satan had been publicized. They even make them public, the security holes, but notable number of them are not yet fixed.